So why did we study the rational root theorem yesterday? So that we could make this list of numbers that are possible solutions, meaning they could be solutions or they could not be solutions, but they're a good place to start. This is great because it narrows down our options from, instead of negative infinity to positive infinity, check these 12 possible answers. Okay, I'd rather check 12 than unlimited. And if a number is not on your list of possible rational solutions, like let's say plus or minus 5 is nowhere to be found on your list, then I guarantee you plus or minus 5 will not work in synthetic guess and check. Okay, so if it's not on the list, it's not even possible, so don't check it. You wouldn't check something that's impossible. That'd be a waste of your time. Okay. So when a polynomial cannot be factored, first we're going to use the rational root theorem to make a list of possible rational zeros, and then we're going to test for solutions. That should say number 2. Now, to test for which numbers are actually solutions, you're going to use synthetic. And remember, I've said this since the very beginning when we started synthetic. I love zeros. Zeros are awesome. It means that you have a factor. It means that you have a solution. So we're going to use the numbers from the list to do synthetic. And if we get zeros, happy faces, then we know we have a solution. If we don't get zeros, we start over and we look for a new one. I highly recommend using pencils in these sections because then you can just erase those 2 lines if the synthetic doesn't work out. Okay. Now, you can repeat number 2 as many times as you want. I recommend repeating it until you have a cubic or a quadratic. And think about cubic and quadratic from way back from chapter or section 4.1. A cubic polynomial has a degree of 3, a highest exponent of 3, and a quadratic polynomial has a highest exponent of 2. But the reason I would say go so far to get a cubic, and really the best case scenario is to go all the way to quadratic. I'll underline that. This is great because you have some skills in your toolbox. You know how to solve quadratics. You can solve by factoring, or you could solve by quadratic formula. So we're actually going to see the quadratic formula come back. That good old friend, the quadratic formula. Now, some cubics can be factored, like they might have 4 terms, so they could be factorable by grouping, but not all cubics are factorable by grouping. So if it's not factorable, I just keep going until I got it to be quadratic. Okay, so you just kind of got to check in with your polynomial and see, like, do I think I could solve and find all the solutions, or should I keep doing synthetic guess and check? Now, this is different from what you did last week on Thursday and Friday, because on Thursday and Friday, I told you what worked, right? I said -2 and 1 are zeros. Do synthetic for those 2. Now, you don't know what's going to work. You have to guess and check to find that. So we're going to do 2 examples, and then if you're okay after 2 examples, I'll give you some time in class to work on the assignment, because synthetic guess and check will take a little bit of time. So we'll start with the first example. Okay. I have several directions here. Okay? I'm telling you to solve a polynomial, which is the same thing as finding the zeros. And I could also say, like, if I wanted only real solutions, I could say find the x-intercepts. Okay? But all of those things sort of mean the same thing. You had a question on last night's homework, right? On the very last page. I think it was like page 194, number 2. It said, which of these is different? And it gave words for directions, like find the x-intercept, find the y-intercept, solve, find the zeros. The one that was different was the y-intercept. Okay, everything else means the same thing. Find the solutions, find the zeros, find the x-intercepts. Okay. Now, I'll be honest. If I were starting this problem like on my homework or my quiz or a test, and I notice that it's cubic and it has 4 terms, I would first check to see if I could factor by grouping. Because if it's factorable, that's probably faster than guessing. So I could, and I'll tell you it's not going to, so you don't have to write this down, but I could try to factor by grouping. And if I tried to factor by grouping, on the first group, I could take out an x squared, and I'd be left with x plus 6. On the second group, they don't really share anything in common, so the only thing I can take out is a plus 1, because I have to put something out there. But this doesn't help because then the 2 groups of parentheses aren't the same, so it doesn't factor. Okay. So this is where we say, okay, what do we do when we can't factor? Go back to the notes that we just took. Start by making a list of possible solutions. I'm going to make the list of possible solutions. I'm going to look for my p's and my q's. So we're going back to yesterday. To get the p's, you're looking for factors of your constant at the back of the polynomial. Even though my constant is -10, remember, we don't really care about the signs. We're just going to list factors of 10. What are factors of 10? 1, 2, 5, and 10. I heard people saying 1 and 10, 2 and 5, right? I like to write my factors in order. They do not have to be written in order. Okay, get your q's. That's up at the front of your polynomial. My leading coefficient is 1, so the only factor for 1 is 1. And then I'm going to create a list of possible rational solutions by taking my p's, 1, 2, 5, 10, and putting them over 1. So my first possible solution is plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. That's 1 over 1, 2 over 1, 5 over 1, and 10 over 1. Can somebody tell me from yesterday, why do I not have 1 over 2, 1 over 5, and 1 over 10? Why are those fractions not on my list right now? Jackson?
Because it's on top of the 2.
Okay, so it's really important when you make the list of possible solutions that it's always p's over q's. And you only had 1 q, right? 1. And you're not writing the fractions q over p. Okay, so make sure you're going in the correct order. Now, this is saying, instead of checking any number that exists from -infinity to +infinity, narrow down your options for guessing to these 8. Make a synthetic box, and you're going to put in the coefficients for the polynomial that you're trying to solve. So the polynomial is x cubed, it's cubic. I have to have an x squared, an x, and a numbered term. So I'll drop those coefficients in, 1, 6, 3, and -10. Remember, if a term is missing, include a 0. That would change things. And then instead of me telling you what to try, you guess one of the numbers from your list. What do you guys want to guess first? David? 5. So you put a 5 out. It's on the list of possible rational solutions, so it could work or it could not work. We'll see. Run through synthetic. Add down to get 1. Multiply. 5 times 1 is 5. Add down to get 11. Multiply to get 55. Is this going to work out? Ooh, no, I can tell it's getting too big, right? So, use my eraser. Get rid of it. What else do you want to try? One. I'll tell you what, I usually start with 1 and -1 because they're easy to do, right? Multiply by 1 or multiply by -1. I like stuff that's easy. So I'm going to add down to get 1. Multiply. 1 times 1 is 1. Add down to get 7. 7 times 1 is 7. Add down to get 10. Oh, hey, That works out. I got a 0. So in my final answer, I'm supposed to find all the zeros. I can now say that 1 is a 0. Or an x-intercept. How many answers should I have for this polynomial? 3. Jace, why did you say 3 for this polynomial?
Because the degree.
Yeah, you look at your degree, your highest exponent. So you know you're done when you have 3 total solutions. And now I only have 1 of them, so I got to find the other 2. Now, since we started with an x cubed, the bottom of our synthetic is now x squared. And so I said, if you get it to be quadratic, I would work with that quadratic and try to either factor it or use quadratic formula. So I'm going to take this and call it x squared plus 7x plus 10. And I'll always check first with these small numbers, can I factor it? So to get that x squared in the front, it must be x and x. And then to get 10 in the back, you need factors of 10. Do you have factors of 10 that will add to make 7? 5 and 2. 5 times 2 will be 10, and then 5 plus 2 will be 7. So we'll put the 5 and the 2 in there, and to be positive for both, they must both be positive. And remember, you can check your factoring by checking your outside. This is 2x. And check your inside term, that's 5x. And sure enough, that adds to make 7x. So then set your factors equal to 0. And I have 2 solutions, -5 and -2. So Damon, you were probably pretty close. You told us to check 5. If we had checked -5, we would have also gotten a 0. Now you could verify that those are zeros by, building synthetic off of the quadratic that we already have. So remember how we did that last week? Okay. Now we know that -5 should work. Let's build off and see if we still get a 0. Add down to get 1. -5 is 2. That's -10. So that works. Okay, so -5 is a 0. And -2 should do the same thing, right? And so I could build off again. Put -2. And add down to get 1. Multiply to get -2. And sure enough, it works. So you could keep checking with synthetic, but there's a chance that nothing else will work because you could have irrational or imaginary solutions. Does anybody have any questions about what we did right there? Now, we'll eventually be like reapplying that to a graph, right? Those are x-intercepts, and then we could use our n behaviors and our y-intercept to draw the graph. But for right now, we're going to concentrate on finding the solutions. Okay, so 1, 5, or 1, -5, and -2 is the answer I want for today. Let's try one more. F of x equals x to the 4th minus 3x cubed plus 6x squared minus 2x minus 12. Could you please make a list of possible rational solutions? You can look back at your notes from yesterday. And then if you get your list done, could you please start checking to see if any of them work? As I'm walking around, I see most people coming up with the correct list of possible solutions. you should have 6 positive and 6 negative possible solutions for a total of 12 possible. But if we go off of what Jace told us at the beginning, we know that only 4 of them could work because we'll have 4 total solutions. So we'll know we're done with the problem when we have 4 answers. And so we just start hunting for them. Set up my synthetic. Did anybody do synthetic and find one that worked? Drees, do you think you found one that worked?
2.
2. Let's try 2 on the outside. Okay. So we'll add down to get 1. 1 times 2 is 2. Add down to get negative 1. Negative 1 times 2 is negative 2. Add down to get 4. 4 times 2 is 8. Add down to get 6, and 6 times 2 is 12. So yeah, that's working out. Okay, so I'm happy. I'd add that to my list of my final answer. So one of my zeros is 2. Now, what I went from was a quartic polynomial to now a cubic polynomial. And I could stop and write out my cubic polynomial to see if it's factorable by grouping. But just by looking at these numbers, I can tell it's not. Because like here, I could only take out a 1, so I'm going to have like some x minus 1 factor in the front. And then in the back, with 4x and 6, I could take out a 2, and I'll have like a 2x plus 3 factor. So those are not going to be the same factors. I need to keep going. Jake's found 2. Did anybody else find a different number that works? Oh, Sahil, what'd you get? You think 3 works? So we'll try it. Put 3 on the outside. 3 times, or sorry, drop my leading coefficient. 1 times 3 is 3. Add down to get 2. Sahil's saying no, it doesn't work. 6, and I can kind of tell I'm going to get 10 times that's 30. That's not working. Sierra, you think you might have one?
Negative 1.
Oh, negative 1. Let's try that one. So we'd add down to get 1. 1 times negative 1 is negative 1. Add down to get negative 2. Multiply to get 2. Or add down to get 6. Oh, yeah, that one works. Okay, cool. So, I mean, it's just trial and error. And sometimes you're going to luck out and find it right away, and then sometimes you're going to have a difficult time finding it. I'd say most of the time it will be within, like, the first 4 tries. If you start with, like, positive 1, negative 1, positive 2, negative 2. I'm guessing one of those will usually work for you. Okay. So I would, rather than jump around to crazy numbers, I'd start with the lower ones because they're going to be easier to do synthetic with. Now this is x squared, right? X and a number. So I'm going to do just like I did on the last problem. I'm going to write that out as a quadratic. X squared minus 2x plus 6 equals 0. And I can do the same thing. I'll try to factor it. Must be x and x to get x squared. Do you have any factors of 6 that can add together to make negative 2? Damon says no. So that means it's not factorable. What do you do when it's not factorable? Well, you could keep going with synthetic, but I'm going to give you a spoiler here. None of the other solutions work. Well, this is the rational root, Kieran, and I'm telling you that none of the other solutions are rational, so that's a problem. I could, Jackson, make us go through and check all of them, but I don't want to do that. David?
Can you solve it like a normal problem?
What do you mean solve it like a normal problem?
Like you could subtract 6 from both sides.
Oh, you're saying subtract 6 from both sides? But then won't you still have x squared and x?
Oh yeah.
That's unhelpful. What do you do, Chastity? Oh, the quadratic formula. Yay! The quadratic formula will always work when you can't factor. So do you remember how I used like my Peppa Pig method? You broke it down into 2 steps. Start with my triangle, which is my discriminant. Okay. So I'm going to do that here. Triangle is b squared minus 4ac in a quadratic. So I'm going to do, that's negative 2 squared minus 4 times 1 times 6. And remember, like, that b squared is always going to come out to be positive, even if b is negative, because you're taking negative 2 times negative 2. So that's going to be positive 4. And then negative 4 times 1 is negative 4 times 6 is negative 24. So my triangle, my discriminant, is negative 20. If my discriminant is a negative number, what do you know about your two solutions? They're going to be imaginary. Because the next step is plug it into the rest of the quadratic where you take the square root of the triangle or the discriminant. Well, the square root of a negative number is going to be imaginary answer. Okay. So finish off my work. X equals negative b plus or minus the square root of our discriminant divided by 2a. So I just have to substitute in x equals positive 2 plus or minus the square root of negative 20 all over 2. And remember, you're not allowed to divide until you reduce your radical. So we know we're going to have an I there, but we have to figure out if we can reduce the square root of 20. It's third hour. Oh, for Mrs. Ingerton? Go check if she's in the office back there. She didn't lend me any directions for you, so maybe she's back there. You've got doubles, 2, so a 2 can come outside with I, and a 5 will stay inside the radical. So then I can write it out as 2 plus or minus 2i square root I all over 2. And now I can reduce each of these by a factor of 2. So we'll get 1 plus or minus I square root of 5. Now, if our goal was only to find the x-intercepts, I wouldn't even keep going, right? Once I figured out it was going to be imaginary at negative 20, I would stop. But since our goal was to find all the zeros, I kept going and kept solving. So I can write out in my list of zeros 1 plus or minus I square root of 5. Okay. So I'd add my negative 1 to my zero list that worked in synthetic. And then I can write my other 2 zeros as 1 plus or minus I square root of 5. If you want to write them out separately so you see 4 zeros, you can do that, but you don't have to. Any questions there?